Hi, and welcome to Section 8. In the previous section, we learned how to use Table View, which is an important UI component for listing items on screen. In this section, we'll request data from an external source, which is a common requirement in many apps nowadays. First, we'll learn the basic concepts of HTTP request. Then we'll do a practical example using URL session request. Finally, we'll cast the received information into local objects. Now we move on to the first video of this section that deals with the basic concepts of REST services. In this video, we're going to take a look at communication with an external server. The class is given to us for communication and the information format and security. What do we do when we need information which is not stored on the device? Imagine we have an e-commerce app. If this app doesn't communicate to any server, it won't be able to know if there are any new products, if the prices have changed, or even know if a product is on stock or not. To solve this problem, we're able to request data over the internet. But how? Apps usually follow an architecture, RESTful, which basically consists of using the HTTP protocol for communicating with the server and get the data on a JSON or XML format. Swift comes with a few built-in classes for this purpose. However, there are many third parties to help us with these kinds of tasks. Which classes do we need to do HTTP requests? There are a few of them. First one we need to know is URL, which represents a full URL with its protocol, domain, path, and query, like http://www.pactpub.com. After that, we have the URL request, which contains information about how we want to do a request, like the HTTP method, which usually is get or post additional headers. As there is a URL request, there's also URL response, which represents the server response code and the HTTP headers. Are these classes enough for doing a request? Not really. Usually we need an additional class called URL session, which is in charge of creating objects of type URL session data task, which will do the request according to the URL request configuration. Finally, we have to know that the URL response doesn't have the response contents. Only the protocol headers and response code, the content itself, is returned on an object of type data, which represents a binary data. If the request fails, an object of type error will be provided. All these classes used to have the prefix NS before Swift 3. For example, URL used to be called NSURL. Let's see some more options in these classes. URL. This class has different initializers. Some of them are failable initializers, which means they might return nil if it wasn't a possible URL. If it wasn't a possible URL we tried to create, one common initializer is URL string, which basically consists of receiving a string and it creates a URL object. If a URL is created as constant with the let statement, they're supposed to be immutable. So once they're created, they can't be changed. On the other hand, we could create a variable URL with var and change its contents. This is a mutable URL. URL request. It only has two initializers, and both of them require a URL object. They also follow the var and let rule, which makes them mutable or immutable. For setting its method, we have to use the property HTTP method if it's not set. Get is the default method. HTTP body is the content we're sending to the server. Remember that technically speaking, we could send binary data, like a picture. That's the reason this property is of type data. Finally, we could set the HTTP header variables with add value for HTTP header. This is very important when our server requires some advanced requests. An important detail we have to remember is that modern iOS apps require some configuration for doing HTTP requests. There's a layer on the network which is in charge of doing the security of the HTTP request, which is called App Transport Security. We have two options for the security guard. One is setting which domains are allowed, one by one, or the second, which is disabling the feature. The App Transport Security is configured on the info plist file. How does the data come from the server? The The server could send information in any format. However, usually there's an agreement for using standard formats like JSON or XML. The way of converting such information into local objects is a local decision and can be done with different solutions. The most common ones are XML parser when receiving XML and JSON serialization for JSON data. If you don't like the ones that are built in, there are many third-party solutions. Remember that as we're doing requests over a network, we always have to consider some issues that might affect our app, including bad networks or loss of network. As requests are asynchronous, we can't consider responses in the same order as requests. Servers also fail, meaning that we might get some unexpected responses. Finally, just a remark that there are some common solutions, like reachability for detecting when the network status has changed. Alamofire, which is a third-party framework which works as a URL session wrapper. SwiftJSON, which makes the JSON conversion more straightforward. In this video, we've learned the theory of communication with a server using HTTP request. Now we have an idea about how to request information from an HTTP server.